Hello everyone, I'm Yağmur Akpoyraz, and tonight me and my team members will make presentation about exploratory data analysis of our data set. Next, please. I would like to mention about what is EDA, and exploratory data analysis is a data analysis method used to better understand data. And this method is used to explore the structural characteristics of data and identify patterns, find missing data, and detect outliers. And we will mention about our data set again. It's our car sales data set. We would like to do using significant features to make accurate price prediction for individuals who are buying or selling cars. Next, please.
Hi everyone, my name is, sorry.
Doğan Can will continue.
Okay, thanks. My name is Doğan Can. I am telling about samples and features. We have 3 million in dataset, sample in dataset, and 16 features and 1 meta in our dataset. 1 million rows have missing values in our dataset, where 1 meta is link. Date time features are date and parse date. Next slide, please. Numerical features are mileage, power, and price. Price is in reason rubles. Categorical features are color, engine displacement, year, body type, full type, transmission, brand, location, name, engine name, and vehicle configurations. Next slide, please.
I have tested something here. Engine name, and vehicle configuration was meta, and we convert them into a categorical feature.
Yes.
I just want to add this.
Thanks. Power year with the least correlation in numeric features, as you can see. Next slide, please. Important features, factors such as engine power, engine displacement, year, mileage, and brand have a significant impact on the price of cars. This is because many factors are considered in determined car price. High-powered engines are sold at a higher price as they improve vehicles' performance and driving experience. Generally, it's sold with larger engine displacement, a higher performance, and higher price. Typically, newest cars are sold at the higher price because they are least used and least worn. Mileage indicates how much the vehicles has been used on worn. Cars with the lower mileage are usually sold at the higher price because they are less used and less worn. Finally, the brand of the car also has a significant impact on the price. Globally recognized and prestigious brands are usually sold at a higher price because the demand is the higher due to quality and brand image. Next slide, please. These slides show the correlation between the features from scatterplot widget. As you can see, power and year with the highest correlation. Next slide. These are missing values. As you can see, 1 million engine displacement value are missing. It is harsh value. Next slide. The missing values are year and engine displacement values, average 1 million data. These missing values are usually on the same lines. If there is no year value, the engine volume value is the mostly absent. Abdullah will continue.
Hello everyone. I'm gonna present you how we impute the data sets. Actually, we have not imputed yet because the data is too rich to impute with our immortal machines. But we decided, we tried lots of techniques to impute data, taking average or something else. Those are failed. Then we tried model-based imputation. We tried CN2 model, CN2 rule induction model, and etc. But the best model is the overfitting model, the mesmerized model, because we derive engine displacement values from engine name. If data set has engine name with engine displacement value, it understands this name of the engine use this kind of value. For example, Series 3 car has 2.0 liter engine displacement. It memorize it and use for imputation. So we use mesmerized model for imputation of the data. We have some results, confusion matrices. As you can see, this is engine displacement results. It's fairly successful. There is just few mistakes, misprediction, but mostly it predict well, it finds well. This is the year model. We have some predictions here. This is 2010, this is 2014, and this is 2018. They will have more error rates, error interest, because the year is not good predicted. So that's it for imputation. Now feature engineering phase is my friend Fahretin present.
Hello, my name is Fahretin, as my friends mentioned that. In feature engineering phase, we thought that we can drive new feature target by taking the algorithm of the base two price values. We take base two price values because it's easy to read the logic of the data, and also we can categorize the price using the linear data obligement from this algorithmic results. Other slide. Okay. We can categorize features such as engine displacement and gear into numerical values. However, we need to first use them as category because it's easier to input them that way. Okay, other slide. On filtering phrase, we thought that there are some mistakes on our data when we try to use out every of them. We thought that there are some parts which is which is this year in the presentation. It's wrote there 1984. I don't know how to read it. Sorry. And it's because of the year's data. There are some variable cars in from this year's, but there are some not too. It's causing an error, and we thought that we don't want this error in our data in our set. Other slide. Sorry, other. Okay, about the millage, we just think that we need to remove some data from village. We thought there are some outliers. We thought that we have two chances to deal with that. First chance is sorry. First chance is this number, and other is two. Address this two, and we thought that we can delete some more data, but actually we want to use them in our predictions. And basically it's there's some advantages and disadvantages. Other side. About missing value filtering, as we mentioned that we use Canon widgets to find our data, and on the other hand, we cannot find some data and which are color, full type, and transmissions. And we thought that we don't want to use in our data in our data sets basically, and with that, the majority of missing data were the engine display and here features. Okay, other side. Is there any questions to ask us?
Is that all your presentation?
Yeah.
Yes.
Okay, Yağmur, let's start with you.
Okay.
So there are some features. You showed us the correlation with the features in the third slide or the fifth slide, right?
Yeah.
And I think the minus 0.5, the most highest one, right? So what do you think of that? If two features has very high correlation between, do you want to remove one of them or do you want to keep both of them? Here, for example, power and price, the correlation is low here actually, 0.6 is not high, but assume that it is 0.999. In the machine learning, do you want to keep these features or not? And why?
I'm definitely not sure, but I think keeping may create some problems, like overfitting. I'm not sure, by the way.
Overfitting is related with the model itself, right? We are talking
Yes.
about the feature.
I'm so sorry.
Anybody can answer this question from the group, from the team?
May I retake the question?
Here, if you look at that, there is the power and price. The correlation between is 0.5, but assume that it's 0.9999. So what are you gonna do with that?
I decided to keep because it affected prediction. It's affected.
Anybody else in the team? Fahretin?
Actually, we don't have to use both of them when we are working with our data. We can use different parts of the data when we are trying to find.
You are not answering to my question. I am asking, look at this correlation graph. In this table, if two features have very high correlation, is it a good idea to keep both of them or is it a good idea to remove one of them? I'm asking a simple question. Not the sum part of the data. I am not talking about data. I am talking about features. Data is the number of the rows, the samples.
Yes.
Here are the features.
Sometimes I cannot speak with the exact words, but on the other hand, I try
about terminology. Otherwise, we got lost.
Yes.
May I change my answer?
Something. So it's not a good idea. Be careful.
Yes.
The rows are the samples, columns are the features. Two simple words.
Yes.
And I'm saying
If they are
if they have very high correlation, what you are gonna do?
if they are showing them, we don't have to use them both. We can use one of them.
Why?
Because it will affect the machine while we are trying to find some
How?
results.
How come?
How? I
May
mean,
I
it's
answer that?
Abdullah can continue. I don't have the real answers, but I just thought that it can affect the work of the machines because it will be extra feature in our in our da- in our data in our feature. Sorry.
Anybody else?
May I continue? Actually, I said I keep that, but because our target is price and there is power and price, this correlation help us to predict with high rate. But if there is a correlation between feature and it's almost one, we can remove one of them because both gives us the same clue.
Yes, because they have similar information, right? So
Yeah.
you don't need to
Yes.
use both of them. That was the answer, right, Abdullah?
Yeah.
Okay.
Just this price value confuse us.
Yes,
because it's our target.
it's the target value, right? And if it is like that, we would like to keep the power as a feature, of course. But I ask if two features. Now let's continue with I think it's the 5th slide, the important features slide. Yes, this is not a good slide at all because it's very busy. As a audience, we cannot follow all these readings on a slide. Please do not write every text onto the slide. There is 7x7 rules. It says that maximum 7 lines, each line maximum 7 words. So it's not a good idea to prevent as a 7 paragraphs. It's not a good idea. Don't do this.
Yes.
Okay. On the impute method slide, you have told us that you have tried imputed several methods, but how can you understand that some method for imputing is better than the others?
We just test it and look at the confusion matrix.
How? How did you test it? I didn't understand. How?
We run those model and we observe confusion matrix results.
So, but you only talk about KNN with K1. What are the other methods?
Because we tried blindly and we don't know what we are doing. So at least we find out the name of the engine gives us the engine displacement clue. So we understand, we make memorized model to predict those informations. Actually, it's not prediction because the models are certain.
Okay. Yağmur, what do you think about these imputation methods? Which one is good for you, or what do you prefer to use? Why you prefer?
Actually, we were trying, so hopeless which one is will give a solution.
After imputing these models,
yes,
how many of the missing values are removed, or how many missing values are filled with some prediction? Yağmur?
we couldn't count it because we dealt many data.
But you have to count them, right? Otherwise,
Yes.
it's not machine learning.
Yes, we missed it here, so sorry about this.
But in the slides, I couldn't see it. Where is that? What is the numbers after how many of
Teacher.
the
Teacher,
Maybe this
can I add
helps us.
some?
There is numbers. There is some numbers here.
No, these are the predictions. I am not asking this. These are the confusion matrix. I am asking that after filling in the missing values, you said that some features are not filled, right? In 2 slides later. Go to next slides. Yes, here you said that you are moving very fast and we cannot read. It is written
Later,
it is written that
you mean that, right?
yes, not here. These are the missing features. After inputting, how many missing values rest? I am asking this.
Actually, we didn't apply the imputing model into our data set because the data is too big. Even 100,000 data takes lots of time, but we have 3 million data. It takes really, it takes
But then don't use
much time.
use the average method. You just assign the average for filling. Why
But
did
it's
you try this?
make higher the error rate.
Why?
Because it takes just average. Because
it only gets the average of that feature and assigns this feature for every missing values. It takes only milliseconds.
Teacher, actually, we try to do that, and we assign every missing values, which are year and I don't
Not
remember.
every missing value. You are saying that only some of the feature missing values are filled in. Am I right? In the
Yes, year and
okay, I am asking
we
that how many of the rows left with some missing values? Very simple question.
about year and mileage, we try to predict every missing values on that. We just add some filtering, as I mentioned that.
So
And
what
with
is the
that,
resulting data set size? I am asking simple question.
yeah, yes,
What is the number of the samples in the data set after filtering out?
I can answer that actually. Our memorized model will predict.
This is before the filtering out. This is
Yeah, I need those information to give you
before. I am asking after data analysis, after filling in the some missing data. What are the numbers?
Yeah. I just need those numbers to explain this. Our model covers whole engine displacement and missing year value. So after that, 100,000 rows we have to discard. So we have almost 2.9 million samples because we have to get rid of power, mileage, fuel type, and transmission rows with missing values.
Can you show me the data table for that? After missing, after filling out, after filtering out, where is that data table?
We don't have any data table because we can't work with.
How can you report this to me? Where is the clue for that? You need to report this, right? Before it was like that, after it is like that because you are changing your data set. Right?
Actually, we can show the data which a part of the data which we are dealing with.
I am not talking about the data. Be careful. I am asking data table. On that data table, it writes the number of the rows after filtering out. Do you really understand what I am asking?
Yes.
But you are replying different things. I am not asking to see some sample of the data. I am not interested in. I am asking a question. You have done something on your data. Now the data set has been changed by you. And I am asking how many data rows rest after you have done something on the data. I'm asking this simple question. And you don't have this result in your presentation.
Yeah.
Do you understand the question? Do you have any answer for that? Taha?
We just try to predict how many sample we can recover. We can.
But you didn't fill in. Am I right?
Yeah, because we have to try it. The only method that came up our mind is trying those imputation on our data set, whole data set. And it takes so much time, so we can't try.
But you can try other methods which are very simple than KNN. Just use the medium, for example. Doğan Can? So what do you think about this?
3 million data, it took us a long time to calculate them all. Thus, we don't calculate all data.
But you have
Actually, we can try average value, mean value, but
okay, basic message. If you alter your data, if you change your data, we did it because of something. After the transform, you need to get the information again. How many rows there? What is the new rows values? So you need to go over your data again and report these numbers. Do you understand? After changing any change on the data, you have to report it.
Yeah.
Enter like that, output like that. The statistics about the data. It's all about exploratory data analysis. Now it is missing. The other question, very quick question. If you go to 3-4 slides later, you talk about the salaries, and you said that you use the logarithmic base 2. Why base 2? In real life, we don't use base 2.
Because it's
we don't
if you use base 10 or base 9
in real life base 2, but mostly we use base 10. Why didn't you use base 10? Yağmur?
If we use base 10, it's
let Yağmur answer this question.
We had some problems in the numeric, so we try to get a clear. We'd like to see a clear scatter plot, so we.
I understood it. I am not asking
yes.
why you are using logarithmic. I am asking why you are using base 2. Why not base 10?
It gave us the most clean.
Did you try base 10?
Yes, we did.
Actually, we tried.
Base 10?
Yes, we tried, yes.
And then?
Paint whole things in yellow.
Say again?
It's paint all the data in yellow.
Then
yes.
why? Why?
Because the range between like this, this is 2 to the 24. If there is a 2 million price, this is in those range. There is 2 million price, there is 1 million, and there is 500,000. So this range help us a lot to observe the data. But if we use them, we cannot get the range. We cannot get informative range, price range.
Okay.
That's the reason.
Okay, you talk about the outliers. Have you checked that? How can you detect and remove the outliers in literature?
Actually, I didn't have any research about it.
Fahretin talk. Okay, Fahret, I am asking to you because you present these outliers to remove some outliers. What could be possible ways to handle outliers? Have you checked in the literature?
Actually, no. I didn't have any research about that. And basically, we make the slides with together, and we don't have our parts in slide. We just share with others.
Okay, I am asking all of your team members, have you checked how can you handle outliers? Detect and then handle what to do with it. Doğan Can?
Yeah, actually, since of proportion, we will say that the in 1960 one car, but up to 1980 is the most car. We will cut under the
Yes, but
1960 years.
here what you are showing just visualization, right? Without
Yes, yeah.
visualization, can you find the outliers? In here, you are just applying some visualization. You check how it appears and you decide it, right?
Yes.
Okay, so please read for about this and then try it. So in your presentation, two things is vogue. I don't understand and you couldn't explain it. If there is missing data, you have to handle it. Handle means that you decide, apply some methods, and the input data set will be changed at the end. So your project will continue with the new data set. And I am asking, what are the new data set statistics? You couldn't explain. Please work on this, handle the missing data, and report what happened after the filling the missing data to your data set, because you are going to continue with data set. Is that clear to all team members?
Yeah.
Yes.
Yeah.
Okay, so please learn about the outliers more, how to detect them, and how to manage them, all right? And apply these to your data set. And this time data set will change again, and you have to report again. For example, how many samples you remove because the year is less than 1984. Be prepared for it and report it. So in your draft final report, please import all these things before the due date. Okay. All right. Can you hear me?
Yes.
Yeah.
Yes,
Yeah.
of course.
Okay.
Any question from the audience? We have 2 minutes.
No hocam.
Okay. Okay. Thank you for the presentation. Please correct or add your new comments and improve your statistical information about your data. Okay.
Okay.
Okay. Take care. Bye.